Okay, here is a video walkthrough of the answer key. Remember, you can fast forward to whatever problems you like. For the first one here, number 5, we have an absolute value graph. I can tell because of the absolute value symbol. This one is going to open down because the negative is in front of the 1/3, and the vertex will be at 0, 0 because there's no number being added or subtracted inside, so there's no horizontal shift, and there's no number being added or subtracted outside, so there's no vertical shift. The only transformations are the negative, making the graph open down, which is called a reflection over the x-axis, and the 1/3, which is a vertical shrink. Now, when it comes to the absolute value graph, we look at the slopes. Okay, for quadratics, like down here, we use the pattern 1, 3, 5. But for absolute value, the number out front for the vertical stretch or shrink gives us slopes because we're going to have a V graph that opens down. So we're going to start at 0, 0 with the vertex. We want to visualize this does not open up. It's a V that opens down. So what we want to do is from here have a V that opens down. So if the slope is 1/3 or negative 1/3, am I going to go down 1, right 3, or up 1, right 3? I'm going to go down 1, right 3 because my V is supposed to open down. And then I'm going to go down 1, right 3 again, and I can repeat that going out to the right. Now be careful if you go to connect the dots, this is not a line, it's a V-shaped graph. So if you go back to the vertex, sometimes it helps to label the vertex. From here, you want to make a V that opens down. So go down 1, right 3, down 1, left 3. Down 1, left 3. You can do that again if you like. If you have a ruler, you can help yourself make a nice straight line, or if you have a note card or a folder, you can do that. Or you can do it freehand if you need to. All right, on to the next one. The next one is a quadratic function. I can tell because of the squared. Okay, so if you have an exponent of 2, you're dealing with a quadratic function. So that's one of your parabolas. This particular parabola is going to open up because in front of the expression that's squared, there's no negative. If there were a negative out front, then it would open down instead. The vertex is determined by the horizontal and vertical shifts. This -3 inside means you're moving 3 to the right, and the -2 outside means you're moving down 2. So the only two transformations here are the horizontal shift right 3 and the vertical shift down 2. There are no other transformations because there's no negative out front and there's no number being multiplied out front. So for the quadratic function here, we're going to go ahead to 3, -2 for our vertex. We want to visualize a U that opens up. It's not a U that opens down. It's a U that opens up. When it comes to the quadratic, we use a pattern for the points. We can't use a slope because the quadratic does not go up or down by the same amount every single time. The absolute value goes down 1, right 3, down 1, right 3, down 1, right 3, or down 1, left 3, down 1, left 3 for this particular example because the slopes are plus or minus 1/3. The quadratic function does not have slopes because it doesn't go down or up the same amount every time. So we have to use this pattern. So this pattern, since the parabola opens up, is how far we go up every time we go right 1. So this is the change in y. So this is the change in y. So it's going to be up 1, right 1. And then this is going to be up 3, right 1. So this is how much you're going up. The change in y, 1, 2, 3. And then we can go up 5. I wrote the wrong thing there. Sorry. Up 1, right 1, up 3, right 1, up 5, right 1. I'm going to write that down because it's the change in y. These numbers are telling you the change in the height. So we go up 1, then we go up 3, and then we go up 5. And again, I'm not quite ready to connect the dots because I'm supposed to have a U-shaped graph that opens up. So I want to use the same pattern going up to the left. So up 1, 1 left. Up 3, 1 to the left. And literally just count. You can just count up 5 and 1 to the left. When you go to connect the dots, it's a good idea to connect the 3 on the bottom first to make sure you make it a nice U. Because it's very easy by accident to make this one pointy. And it's not a V-shaped graph. It's not an absolute value graph. It's a parabola. Because of the squared, it's a quadratic function. And now we continue on to number 7. Number 7 is another absolute value graph. I can tell because of the absolute value bars. This one's going to open up because the number out front doesn't have a negative. So it's going to be a V because it's absolute value, and it's going to open up as opposed to opening down. The vertex is going to be at -1, 0. That's because the vertex is usually 0, 0, but for this one, we have a horizontal shift left 1. Whatever number you're adding or subtracting inside is your horizontal shift. So +1 inside sends us left 1. There's nothing added or subtracted outside, so that's why we're not going up or down at all. So our vertex is just going to be over here at -1, 0. To make our graph, when it's absolute value, we use slopes, okay? So, because each half of the V is actually just part of a line. So our slopes are going to be plus or minus 3/4 because that's the number out front, which is a vertical shrink. When the number you're multiplying by out front is bigger than 1, it's a vertical stretch. When the number you're multiplying out front is smaller than 1, if it's a fraction between 0 and 1, it's a vertical shrink instead. And remember, when you decide stretch or shrink, you ignore the sign for a moment. So don't worry if this is positive or negative, just look at the number itself. That's going to tell you whether it's stretch or shrink. Looking at whether the number out here that's being multiplied is positive or negative tells us if it opens up or down. This one opens up because there's no negative. There's been no reflection over the x-axis. So these are the only transformations. So we start at the vertex and we use our slopes. Visualize that this opens up, okay? Because when you use your slopes, you're looking at rise over run, and you have to decide from here if you want to go down 3, right 4, or up 3, right 4. Well, if this V is supposed to open up, you can't go down this way. You don't want to open it down. You want to open it up instead. So you need to go up 3 and right 4. You can do that again to get more accuracy. Okay, and be careful if you connect the dots, it's not a line. It's supposed to be a V that opens up. So from here to make a V, we're going to go up 3 and left 4. And you just count. You just count on the grid. So go up 1, 2, 3, go left 1, 2, 3, 4. All right, and then you can make your V graph, and it should be pointy because it's a V-shaped graph. Remember, don't end your graph here and put the arrow, take it all the way to the edge of the graph paper, and then put your arrow, please. All right, 2 more to go. Here's the next one. This is just a line. There's no absolute value, and there's no squared anywhere. Okay, there's no exponent of 2. Let me rewrite that. There's no exponent of 2, and there's no absolute value. That can look like an 11, so let me just put no absolute value. All right, no absolute value bars, no exponent of 2. It's just a line. So what we're looking at is y equals mx plus b. Our slope is 2/5, and our y-intercept, that's what b is -3. So as it said in the directions, if it's a line, just go ahead and graph it. None of these things are relevant to the way that we graph lines. Okay, lines don't have a vertex, and we don't discuss transformations of lines. We just use the y-intercept and the slope. So the y-intercept, remember, goes on the y-axis. A common mistake is to put it on the x-axis. And then for your slope, remember this is rise over run. So we want to go up 2 and right 5. Up 2 and right 5. You can also go down 2 and left 5, because remember, if you go down 2 and left 5, well, negative over negative is positive 2/5 anyway. So that's why you're allowed to go down 2 and left 5 if you like. Give you a little more accuracy. And then I'm going to use a ruler for this one. I don't trust myself to make a straight line. All right. With the V-shaped graphs, I can do that, but this is a lot longer because it goes across the entire graph. That's the line we're looking for. And remember, it's an uphill line because the slope's positive. If the slope had been negative, we'd want a downhill line instead. And finally, our last one is another quadratic. I see an exponent of 2, so I know it's a quadratic function. This is going to open up. It's a u that opens up. It's a u because the exponent 2 means it's quadratic. It's a parabola. It opens up because the 1/2 is positive. If we had a negative out front being multiplied, then it would open down instead. Now for the vertex, we're only interested in horizontal and vertical shifts. There's no horizontal shift because there's no number inside with the x before the squared. This -3 is outside after the squared, so that's a down 3. So by the way, we can write down, we have a vertical shift down 3. And then the other change to the x squared here is the 1/2, and that's a vertical shrink. And again, when you determine stretch or shrink, you ignore whether it's positive or negative. Okay, you just look at the number itself, technically the absolute value of it, but just look at the number itself. And if it's between 0 and 1, it's a shrink. If it's bigger than 1, then it's a stretch. So this is a vertical shrink by 1/2. All right, and we're ready to graph. Our vertex is going to be at -3 on the y-axis, 0, -3. Visualize a U-shaped curve that opens up. And for quadratic, we use the pattern for the points. The pattern for the points is 1, 3, 5. Because of the vertical shrink, what we're going to do is we're going to multiply the change in y by 1/2. Okay, if this were 2, we'd multiply these by 2. If this were 3, we'd multiply these by 3. But since it's 1/2, we're going to multiply these by 1/2. And just like last time we did that, we get 1 times 1/2 is 1/2. 3 times 1/2 is 3 halves. That's 1.5 if you like, or 1.5. And then 5 times 1/2 is 5 halves, which we, last time we did that, we said that's 2.5. So we can always change it to a mixed number instead. So this is the new pattern. If you have a vertical stretch or shrink, you multiply the pattern by whatever the number is. So in this case, 1/2. And this is the new pattern for the points. So we want this to open up. So from the vertex, I'm going to go up 1/2. I'm going to go up 1/2 and right 1. This is the change in y for every 1 unit to the left or right. So I'm going to go up 1/2. There we go. And then now I'm going to go up 1.5 as I go right 1. So I'm going to go up 1.5. That puts me here at 2, -1. And then I'm going to go up by 2.5 as I go right 1. And that's part of my U curve there. Now to get the rest of the U, instead of going up 1/2 right 1, we're going to go up 1/2 left 1. And then we're going to go up 1.5 and left 1. So from the vertex, it can be very helpful to label that. We're going to go up 1/2 and left 1, up 1.5 and left 1. So we should have a point at -2, -1. And then we're going to go up 1, 2.5, left 1. And we're going to have a point at -3, 1.5. This should be a U-shaped curve. Don't make it pointy. Okay, so go ahead and make it a U shape. And don't stop your graph where you stopped the points. Continue to the end of the graph paper and then put your arrows to show that this continues forever in those directions.